Hello students, last time we have discussed about the fluctuation of energy in detail. Okay, there is one figure and we have discussed T theta diagram briefly. Okay, for the turning moment diagram of single cylinder double acting steam engine. Okay, now today we are going to discuss on the maximum fluctuation of energy. So last time we have just introduced what is the maximum fluctuation of energy. So what is the maximum fluctuation of energy? It is the difference between maximum and minimum energy is known as the maximum fluctuation of energy. Difference between maximum and minimum energy. Okay, now how we can determine the maximum fluctuation of energy means how we can determine the maximum energy and minimum energy. So here turning moment diagram is given to you. This is a turning moment diagram, T theta diagram. Okay, now here you can see from the T theta diagram the horizontal line AG represent the mean torque, means here AG represent the mean torque, then A1, A3, A5 be the area of above the mean torque line, and A2, A4, A6 be the below of mean torque line. This area represent the some quantity of energy which is either added or subtracted from the energy of moving part. मतलब कि यहाँ पे आप देख सकते हो mean resisting torque की line you can see here, and from this line there is A1, A2, A3 having a different area. Okay, so here you can see above A1, A3 and A5, and below mean resisting torque there are A2, A4 and A6. Okay, so what is this? This is above and below the mean resisting torque line. Okay, area. Now energy, if we talk about the energy at A, let's assume that energy at A is equal to the energy E. ओके तो हम एज्यूम कर रहे हैं कि जहाँ जो ए पॉइंट है वहाँ पे एनर्जी ई है. ठीक है, उसके बाद यहाँ पे ए से बी तक आए तो एनर्जी कितनी हुई? अब ए से बी तक आए तो एनर्जी एट बी इज इक्वल टू ई प्लस ए वन. सो इनिशियली वी एज्यूम इट इज ई, देन एट द पॉइंट बी it is E plus A1, means here point B it is E plus A1 because it is a positive. Okay, upper one is take a positive and lower one as a negative. Now when come from B to C, it is again here it is called the minus A2. Okay, so energy at C it is E plus A1 minus A2. Okay, sorry for disturbance. Now energy at D, if we talk about the energy at D, so it is E plus A1 minus A2 plus A3. Same way for E, it is again minus A4, we have to add. Again if we consider F, then A5 we have to add. So like this, energy at the G means the end point, energy at the G is E plus A1 plus A3 plus A5 minus A2 minus A4 and minus A6. So suppose here during this situation at the point B, say here the energy is maximum. This is an assumption. Okay, in example it may be changed. So suppose at the point B it is maximum and at the point E it is minimum. If you calculate, then here it is maximum and here it is minimum. So the maximum fluctuation of energy that we talk about is equal to the maximum energy, means E plus A1 minus minimum energy, means this one. Okay, so here is equal to A2 minus A3 plus A4. So by this way we can find the maximum fluctuation of energy. Now second definition, here small definition is there, coefficient of fluctuation of energy. So it may be defined as the ratio of, you know, the maximum fluctuation of energy, right? So it is the ratio of maximum fluctuation energy to the work done per cycle. Now maximum fluctuation of energy we have discussed in detail as per above. And what is the work done per cycle? So work done per cycle is equal to T mean into theta, and theta is the angle turned in one revolution. Okay, so 2 pi in case of 2 stroke and 4 pi in case of 4 stroke. Okay, so work done we can find out by this way, and the work done per cycle, Newton into meter or joule, may be obtained by using the following relation. Now second, we can find out the work done by P into 60 upon N. P is the power transmitted. Okay, P into 60 upon 2 pi N. Okay, so here P upon omega, and here if we talk about N, that is number of working stroke per minute. So by this two way we can find out the mean torque. Okay, or we can say work done per cycle. Now I think this is enough for today. Let's discuss one more, coefficient of fluctuation of speed. So it is a very small theory. Coefficient of fluctuation of speed, it is denoted by CS. So it is the ratio of maximum and minimum speed. It is the ratio of, it is a difference between maximum and minimum speed during a cycle is called the maximum fluctuation of speed. So here this is the maximum fluctuation of speed, N1 minus N2, maximum and minimum. This is the maximum fluctuation of speed to the mean speed. Okay, I hope you understand. Let me discuss it again. So here N1 minus N2, what is this? This is the maximum fluctuation of speed to the mean speed. So it is the ratio of these two. It is called the coefficient of fluctuation of speed. So here it is in the form of angular speed. Okay, and here it is the linear speed, linear velocity. So by this way we can find out the coefficient of fluctuation of speed. Now next topic is energy stored in a flywheel. So here you can see the flywheel. Here mass m is the mass of this flywheel, k is the radius of gyration of this flywheel in meter. Now here there are so many things given. I is the moment of inertia, is equal to mk square, you know very well. N1 and N2, that is the maximum and minimum speed, omega 1 omega 2 simultaneously. N is the mean speed, N1 plus N2 by 2. Omega is the mean angular speed. Then CS is the coefficient of fluctuation of speed. We have discussed all these things. Okay, now we know the mean kinetic energy of flywheel. You know the kinetic energy of flywheel, E is equal to 1/2 I omega square. So here instead of I we can put m into k square omega square. Now this is the mean kinetic velocity of flywheel, mean kinetic energy of flywheel. Now here delta E, we know the maximum fluctuation of energy, that is the maximum kinetic energy minus minimum kinetic energy. So here we assume this one is the maximum kinetic energy, I omega 1 square, and here this is the minimum kinetic energy. So after deriving, you just pause the video and solve out these things. It is very easy. Okay, so finally we got the answer like I omega square omega 1 minus omega 2 upon omega. Here you can see omega, we divide here omega and put it square over here. Okay, so this is just manipulated. So omega square here omega. So I omega square CS, because we want to comes to this equation, we want to use CS, that's why we multiply omega above and below. So I omega square CS, so is equal to mk square omega square CS. So finally 2E CS. Okay, so E is equal to 1/2 I omega square. So here 2 we can add E CS. Okay, so you can find out by this way and this way. These three equation you can get over here. So this is the equation. Then next is the example. So energy stored in flywheel you can find out by these three equation. Okay, so today's session I think this is enough, and next in next lecture we will discuss the examples. Okay, so be ready for that and just prepare this one, revise this one. Thank you. Jai Hind, Jai Bharat.